Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 16 is rational and irrational numbers. Okay, classwork opening exercise says to explain how to use a number line to add the fraction 7/5 plus 9/4. You may recall doing this back in 8th grade, I believe. But anyhow, here we go. So I have a number line, and let's just start with, let's do a segment like so, a little bit thicker. How about blue? Okay. So it says explain how to use a number line to add the fraction 7/5 plus 9/4. Okay, so if we were to do this, 7/5, I broke up the integers into 5. Okay, 1/5, 2/5, 3/5, 4/5, 5/5 is 1. So 7/5 would go from, oops, what happened to my tool? I want this. Zero to 7/5 is right there. A little bit tough with this program. Just give me a sec. Right about there. Okay, so there's 7/5. Now, if I do the same thing on the next number line, I have gone from fifths to quarters. 9/4, 1/4, 2/4, 3/4, 4/4 is 1. We want 9. So I start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9/4 is right here. Okay. Let's add those buttons on the end. And there is our two segments. All right, so let me just make them the same. So now what we want to do is add them. Well, if I take my 9/4, which would take us from 0 out to here, and if I take my 7/5, okay, actually let me put the blue one first and go in the right order. So here is 7/5 plus 9/4. And that will take us out to, and this isn't marked real well, 3 is right here. Here's 2. And here is 1. Okay, then here, and then 4 is right here. So this is broken up into 20ths, okay? Our common denominator of 5 and 4 is 20. Okay, common denominator. So anyhow, it comes out to be 3 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 and 13 20ths. Or we could call it 73 20ths. And that's what 7/5 plus 9/4 is. So here's how you would use a number line to add those two fractions. Okay, so the distance 7/5 comes out to be 28 20ths. I'm just going to show this. Okay, because to get to 20, we have to multiply by 4 over 4. 7 times 4 is 28. And then to get to 20, we have to multiply 4 times 5, and 9 times 5 is 45. So this is going to be 45 20ths. And then when you add them, 28 plus 45 is 73. So we get 73 20ths, or 3 and 13 20ths. So that is how you use a number line to add fractions. Okay, part B now says, convert 7/5 and 9/4 to decimals and explain the process for adding them together. So 7/5 is going to be 1 and 2/5. Okay, and then converting that is going to be 1 point. And since I want tenths, I need to multiply by 2, so that's 1 and 4/10. And then if I do the same for 9/4, I don't need to rewrite it. 9/4, 4 goes into 9 2 times with a remainder of 1. So that's 2 1/4, which is 2.25. So to add these, I'm just going to add a 0 here. So we have the same number of decimal places. And then you just simply take the 1.40 plus 2.25 and add your hundredths position, 0 plus 5. Add your tenths position, 4 plus 2, add your ones position, and we get 3.65. Okay, and that is how you convert to decimal and add them together. Okay, so the reason we did page 1 was to show that we can add rational numbers, but what happens when we get to a logarithm and they're irrational? So exercise 1 says, according to the calculator, the log of 4 equals this, and the log of 25 equals this. Find an approximation of the sum of those two logs to one decimal place, or to an accuracy of 10 to the negative 1, which is 1/10. Okay, so what we're going to do is we're going to say the log of 4 is less than, and we're going to round down here. So it's 0.60. It's less than the log of 4. And if I round up, then the log of 4 is less than 0.61. Okay, so that's just rounding it to 2 decimal places. And if I do the same for the log of 25, then the log of 25, we're going to find an upper bound and a lower bound approximation. And the lower one would be 1.40, rounding to 2 decimal places, or 1.39, I guess, if you don't round, 1.39. And then rounding it up would be 1.40. So 1.397 is between 1.39 and 1.40 is what we're trying to say. Okay, so then if we take the sum of those two, then we take the log of 4 plus the log of 25 is going to be between the sum of the lower bounds and the upper bounds. So 9 plus 0 is 9, 6 plus 3 is 9, 0 plus 1 is 1. So we know the log of 4 plus the log of 25 is more than 1.99. Now what is it less than? 1 plus 0 is 1, 6 plus 4 is 10, carry the 1, and we get 2.01. So we know the sum of log of 4 plus the log of 25 is between 1.99 and 2.01. So now we can say the log of 4 plus the log of 25 is an approximation of 2.0, rounding to the accuracy of 1/10. Okay, so there's number 1. So pause the video, see if you can do these, because these were all exercises. I just used exercise 1 as the example, and see if you can do this. Okay, so here we go. We're going to do this again. Now we want to find an accuracy out to 2 decimal places, to the -2. So we always want to go one more. So all we're going to do is, let me just save some time here. Actually, no, let's just do it. The log of 4 is going to be between, and I need to show this up here. So now we're going to go out instead of just 0.60, we're going to go to 602. So 0.602, and then that rounds up to 0.603. And then the log of 25 is going to be between 1.397, truncating it, and then 1.398, rounding it up. So then we say the log of 4 plus the log of 25 is going to be between the sum of these. So 7 plus 2 is 9. 9 plus 0 is 9. 3 plus 6, 9. 1 plus 0, 1. So now we're up to 1.999. And then 8 plus 3 is 11, carry the 1. 9 and 0 and 1 is 10, carry the 1. 6 plus 3 is 9, plus 1 is 10, carry the 1. And we get 2.001. Okay, so then we finally say the log of 4 plus the log of 25 is an approximation of the value that's between these two, which is 2.00. Okay, now it says out to an accuracy of 10 to the negative 8. So to do that, we have to go out 9 decimal places. So let me just see how many they gave us. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be right here, out to that 1. Okay, so the log of 4 is going to be greater than 0.602059991. Okay, let me just fix that. Okay, just to save time, I wrote them out to 8 decimal places, which I put markers here. And I'm going to do the same with the log of 25. Okay, so that's going to be between. Okay, so I fixed this. I had put the wrong upper bound for log 4. I did the log of 25, so I moved that down. So we're going to take the log of 4 is between 0.602059991 and 9992. Okay, so it's between those two. And then a log of 25 going out to 8 and then rounding up to 9 on this side. All right, so then we're going to add them. So we're going to say the log of 4 plus the log of 25 is going to be between, oops, just switch to black for the rest of this. It's going to be between the sum of these two values. So 8 plus 1 is 9, 9 plus 0, 9 plus 0, 9 plus 0, 5 plus 4, 9 plus 0, 7 plus 2, 9 plus 0, 6 plus 3, 0 plus 1. 9 plus 2, 11, carry the 1. 9 and 1 is 10, carry the 1, 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 10, carry the 1. I didn't give myself enough room. Okay, where was I? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're at 9 and 0 plus that 1 carried 10 and 6 plus 3 and 0.2. So it's 2.00000001. And so therefore we can now say the log of 4 plus the log of 25 is approximately 2.123456788. Okay, so it's approximately 2. All right. So 4 now says, make a conjecture. Is log of 4 plus log of 25 a rational or an irrational number? Okay, so we'd say it appears that the log of 4 plus the log of 25 equals 2 exactly. So my conjecture is that the log of 4 plus the log of 25 is a rational number. Number 5 says, why is your conjecture in exercise 4 true? Okay, so this is going to lead up to our last lesson, which was lesson 15. And since the log of some number x plus the log of some number y equals the log of those two products, then in our situation, we have, so since this is true right here, we can then say, therefore, the log of 4 plus the log of 25 equals the log of 4 plus 25, which equals the log of 100, not plus, times. 4 times 25 equals a log of 100. Okay, so converting this to exponential equals some value, let's call it z since I already used x and y. So the base, so it'd be b to the z has to equal x, and our base is 10, and some number z equals 100, well then z has to equal 2. So the log of 100 equals 2, which is rational. And that's what we got up here. Okay, so this page says, remember that the calculator gives the following values for the log of 4 and log of 25. Find the value of log 4 times the log of 25 to 3 decimal places. So the first thing we're going to do is take the log of 4, and we know it is between, okay, let's see, I don't know if I want an equal sign. I haven't been using equal signs because it can't be equal to can't be equal to an irrational number, can't be equal to a rational. So how about we just get rid of those equal signs? And we're going to, if we're going to go to 3 decimal places, I need 4 in my approximation. So 0.6020 and 0.6021, rounding this up. And then we say the log of 25, again, is between 1.3979 and 1.3980. Okay, so then when I multiply these two, let's just use the calculator for time, just to show what's going to happen here. 0.6020 times 1.3979 equals 0.841538. So I'm just going to write this whole thing, 0.8415 and it was 358 is less than the log of 25. Actually, the log of 4. Times the log of 25, which will be less than, and then we're going to do 0.6021 times 1.3980, and I get 0.841738. 0.841538. 8417358. Okie dokie. All right, so 8415, 8417, rounding to 3 decimal places, 1, 2, 3, it's this 1 right here, and 1, 2, 3, it's this 1 right here. So now we can conclude that the log of 4 times the log of 25 is approximately 0.842. Okay, now they say to find it to 5 decimal places. So let me just move up a little bit here, start again. Log of 4 is between 0.60205, okay, 60205 and 0.60206. And the log of 25 is going to be in between 1.39794 and 1.39795. Okay, so then we multiply these. So the log of 4 times log 25 is going to be between, and then we do 0.60205 times 1.39794. And I get 0.841629777. 0.84162977. And then over here, I do it again. It's going to be 0.60206 times 1.39795. Did I do that right? 1, 2, 3, 4, 5 to 5 decimal places. No, I didn't go enough decimal places. So let me fix this just 1 second. Okay, so when I was multiplying that, I noticed I didn't go out far enough. If we're going to round to 5 decimal places, we need 6 decimal places to do our calculation. So now I just need to type these in. I fixed it. I went out 1 more decimal place to save time. So it's 0.60259 times 1.39794. Enter. And let me just do this so I can see both. And it's going to be 0.8416423. 1, 2, 3, 4, 5, 6, 7. We're only going to 5 decimal places. That's far enough. I only really needed to go to 6. 8.8416. 4, 2, 3, 1, 2, 3, 4, 5, 6. So I don't even need this 3. And then 0.60260 times 1.397941. And I get 0.841644. Okay, so now I can conclude that the log of 4 times the log of 25 is, oops, I was going to say equals, is approximately 0.84164. Okay, rounding to 5 decimal places. So number 8 says, does your conjecture from the above discussion appear to be true? Okay, so in the video, there was no way to state a conjecture from students. So I just brought in an example. So it said, no, the work from exercise 6 shows that the log of 4 times the log of 25 does not equal the log of 29, which is what some might say, because it's multiplication. We take 4 plus 25, which is 29. And the log of 4 times the log of 25 does not equal the log of 100. So what is the log of 29? Did we even check that? The log of 29 is 1.4623. So the log of 4 times the log of 25 should give us the log of 4 plus 25, which is 29, but it did not come out to be true. So you can't take two logs being multiplied and just add the two numbers. It doesn't work that way. If we're adding the two logs, we can just multiply the numbers, but it doesn't work in the reverse. Okay, page 4 brings us to the end of lesson 16. Review the lesson summary and go to your problem set.